Hello students, I have told you about the nuclear fission and nuclear chain reaction. Now I will tell you about the difficulties in chain reaction. Now there are two major difficulties in chain reaction. There are two difficulties in chain reaction. Number one, in nature, uranium-238 is found in abundance than uranium-235. Uranium-238 is 99.7%, while uranium-235 is only 0.7%. So the neutrons emitted in fission uranium-235 are absorbed by uranium-238 and the chain reaction stops. So what must be there? There may be two things in this. To overcome this difficulty, there are two ways. Number one, uranium-235 should be separated from uranium-238 by diffusion but this process is very tedious. Second, moderators like D2O or graphite must be used to slow the neutrons emitted by fission of uranium-235 so that they could collide the next uranium-235 nuclei. The second, the neutrons emitted by fission of uranium-235 slow after moving a distance of 10 centimeter. It means there should be a minimum mass or volume of fissionable material so that the emitted neutron could not escape. This minimum mass is called the critical mass. Of fissionable material. So these are the two major problems. First is that in the nature the uranium-238 is in maximum amount and 235 is very less. So when the uranium-235 is fissioned, then the what neutrons are produced, they are absorbed by by uranium-238. Because the uranium-238 absorbs the slow neutron, which have the energy less than 1 mega electron volt. So there are two things that the uranium-235 must be separated from the uranium-238, but this is very difficult because both are found in the combined state. But second is that there must be use of quadrators so that the neutron emitted could slow and they may undergo the nuclear fission of uranium-235. And then the second major difficulty is that the neutron emitted from uranium-235 move up to a distance of 10 centimeter. This means that if the size of the material is less than 10 centimeter, then they will escape and will show no nuclear fission of uranium-235. Naturally, there must be a critical or a definite size so that they could not escape from the fissionable material. And this minimum size of the material is called the critical size or the critical mass of the fissionable material. So these are the two major difficulties which stops the nuclear chain reaction. So if these difficulties are overcome, the chain reaction may continue and there we can get a large amount of energy. So these are the difficulties. So you all like, share and subscribe this video. Thank you.